1, go.
Good morning, class. Welcome to Maths for grade 11 in our new time slot on our new platform. It's 9 o'clock and we are back on Zoom. Welcome to all the first timers who haven't been here before, and welcome back to those who've been here before. So we are working on always trying out better, different, and more user-friendly platforms for you guys to maximize your experience. And that is why we had a change from Zoom to Teams, and now we're back on Zoom, because Zoom has updated and brought in some features that make it better again for us to use. As per always, we are continuing with trigonometry. We are almost done with trigonometry. I am your grade 11 teacher, Miss Shabalala, and you guys can get a hold of me on Twitter at _Mbaliti. First things first, to those of you who are first timers, a very warm welcome to you. I'm hoping you guys are coming with enthusiasm, with questions. I'd also like to say, guys, please refer to YouTube or to the Africa Team Geek sites for our previous classes so that you can come on, get up to standard with where we are in terms of understanding why we use certain shortcuts, why we use certain methods. All this was previously discussed in our classes. Our classes, each class is built up to the next class. But most importantly, I'm here if you guys need to ask anything. Right? First things first, we have our rules of engagement. Please respect everyone because we're all here to learn. Number 2, there's no such thing as a dumb question, so please don't be shy. Please ask away. Number 3, we're back on Zoom, so you can raise your hand if you have a question, and you will be unmuted when you can ask the question. Number 4, please type your questions in the chat if you are shy to raise your hand. I will also be answering those questions in the chat. Number 5, we won't be tolerating any vulgarity, guys. Please let's respect each other. It goes back to respecting each other. And it also goes back to my next rule about not taking the opportunity to learn away from someone else. I believe that maths is a fun subject. This is a short week, so we've got quite a lot of ground to cover. I'm hoping you guys can keep up and we will all have a good week. Right? Lastly, please extend the link to your friends, guys, so that they could also join in. It's always great to have more coverage to assist more people. And as I said, please go back to our previous classes if you need to catch up, if you need understanding. And I'm always happy to take your questions. If you have questions on previous classes, you're also welcome to contact me on Twitter at _Mbaliti. I'll definitely address those for you. So in terms of questions today, how we work is, if I move slightly ahead of the time at which you raise your hand, when you ask your question, you are going to refer to class example number 1 or 2 or whatever and say, in class example number 2, you did that. Why? Or whatever the question is. But yeah, guys, let's hopefully have a good class with some engagement. I'm hoping for some engagement from you guys. The rule that I did not put in here, but is in your chat and is one of the most important rules is, guys, please keep your cameras off. Please switch off the video function on your computers and laptops. We are working without that. Thank you. And so we will begin our class today. So today's objectives are pretty simple, pretty straightforward. I had not left you guys with any homework on Friday, wanting you guys to enjoy the long weekend. And I had told you guys that we are starting on a relatively new part of trigonometry today. Today in trigonometry, we are working on quadratic equations. So we're going to start with a very quick revision of quadratic equations. I'm sure you guys can remember this from grade 10 and quadratic equations from the beginning of this year as well. So yes, we are going to just it's a very quick revision, guys. because I'm hoping that the principle is deeply entrenched in your knowledge and you guys can use it just for just, right? And what we will actually be then moving forward to today is picking up from trigonometric equations, which we started last week. We will be solving quadratic trigonometric equations in a given interval, and also we will be determining a general solution where an interval is not given in a quadratic trigonometric equation. So guys, I'm going to ask to call them QTE because quadratic trigonometric equations is taking a while. So I will be referring to that as QTEs for the rest of the lesson, hoping that you guys can keep up, right? First things first, our quick revision, literally one slide. So here is a question. It's a quadratic equation that I need you to solve for. If you remember quadratic equations, if you remember functions and you have your quadratic graph, we know that the fact that we have a square means that we've got two possible answers on this. We go back and we apply our factorization to get the two possible answers. So here's our graph, guys. And I have on my graph depicted this very equation on here, right? And I have made y 0, basically. Yeah, I've made that 0, right? And I'm saying to you guys, where y is 0, what is x? And it's very clear from the graph that where y is 0, there are two possibilities for x. X could either be 2 or x could either be 3. And we should be able to detect that information from when we solve a quadratic equation. So remember factorization, what factors give you a 5 and also when multiplied give you a 6? It's a 3 and a 2, right? So we factorize our formula that simply and we say x minus 1 times x minus 3. That will take us back here. And also that will give us our two points of x on the graph, right? So next from here, we know we separate to say you will deal with this part of the equation on its own, and you will deal with this part of the equation on its own right there. And both of them will be equated to whatever is on the right, which usually should be a 0 because we are factorizing. Okay, so we'll start with number 1. Simply what you do on the left, you do on the right because we are trying to get x only on the left. So we're going to add 2, and that puts us at an answer of x is equal to 2. Same applies this side. What you do on the left, you do on the right, and simply we find ourselves finding that x is equal to 3. Right, guys? And here on our graph, very clear. X is equal to 2 or x is equal to 3. And both 2 and 3 will make this equation true. Substituting both 2 and 3 into the calculation, into your original equation, will make this equation true. Reminder what we had said last week. We said last week, when you are finding values for equations, what you are saying is you are finding the values for which the equation is true. So at point x being 2 and at point x being 3, those are the points at which your y will equal to 0. Those are the points at which your equation will be true. So guys, I think you remember this quadratic equations. It was normally this simple. And I want to say to you, this is exactly how we solve QTEs. It is not any different. The only difference is that we obviously have our trig functions, cos, sine, tan. But principally speaking, it's actually exactly the same way. And so what I'll be doing for today's lesson, I'm going to be going through a few examples where we'll be resolving trig equations, right? In one particular example, I've specified an interval to show you or to remind you the kind of answer that you should come out with when you have a specific interval. Number 2, I have said, please just give me the general solution. From there on out, which in each example that follows, you and I are going to be in conversation around where do we stop at getting the answer. So I hope everybody is on the same page as me. Everyone is happy and freshly reminded of quadratic equations as we prepare to move into QTEs. This class is mainly focused around class examples, guys. Very deliberately so, just to get you guys into the groove. I'm hoping you guys can keep up. Please ask your questions if you have questions. And what I would like to also say is that remember that in maths, the final answer is the same, but the way in which we arrive may differ, and that is okay. I'd also like if you guys can come to me and say, ma'am, I would not do it like that. I would actually have done it in such and such and such a way. I'd actually also appreciate that, guys, that level of engagement, your feedback. I'm always happy to engage you guys, right? So let's start with today's example. In our first example, I'm saying to you, determine the general solution. So here, I'm giving you what you ought to do. Just determine the general solution. If you guys remember from last week's classes, or if you go back to the videos online, you'll see that your question should dictate to you the extent to which you continue with your answer. But if your question does not dictate to you, then you simply determine a general solution, right? This is our equation. Our equation here says 4 sine squared beta is equal to 3, right? Guys, there's no funnies. We've been doing trigonometric equations for some time now. And so we literally keep up the momentum. Like, there's absolutely nothing weird going on. It's not strange, right? And so there's 2 ways to resolve this. I'll give you both. We'll chat through both, right? The first one, I would say to you, take the 4 to the other side. So divide both sides by 4, right? And be left with your sine squared beta. Then to get sine beta, you know that you need to find the square root of a square, right? And you know that you would come at your 2 answers, where when you're finding the square root of a number and it's a duplicate, you know that it could either be positive or negative. Both these are going to give you the same answer when you square the sign, right? What you could have also done, which in this case, because factorization is not that straightforward, I would not have advised. You could have said 4 sine squared beta minus 3 is equal to 0. And then you could have said 2 sine beta minus square root of 3 and 2 sine beta plus square root of 3. And that would have put you in exactly the same position that you are now. I would not have advised that method. But again, we use methods that work best for us in maths. When the mathematical logic is there, it's fine as long as we get to the same answer. The other thing I wish to remind you guys of is how we mark in maths is we say, let's hypothetically say you had come out with beta being equal to a half by mistake. But you find your beta or sine beta being equal to a half, but you find your reference angle accordingly as your 30, and you move with the half incorrectly. So the only time we will penalize you for getting the number wrong is the first half. From there on, if you've continued the mathematical logic, you will be marked correctly for principal marks. I'm hoping that makes sense, guys. But anyway, so we're here now, and we know that so sine in this case could either be positive or could either be negative, right? We ask our usual question. Also, then we get our reference angle. In this case, because it's a plus and a minus of the same amount, we only need to get one reference angle. There would be a time where the one side is equal to a half, the other side is equal to 1. In that case, we will get 2 reference angles, a reference angle for the half and a reference angle for the 1. Right? That's one thing. And then the other thing that I should mention is, I'm forgetting what I should mention, but I'll catch it as we continue. So yes, we have our reference angle. Oh yes, what I wanted to mention is, remember guys, when we are finding our reference angle and we are keying our stuff into the calculator, we are going to say sine to the power of -1, and in brackets you're going to put √3/2. You always leave out the sign. Leave out the sign, right? The sign becomes irrelevant when you are finding the reference angle. What we use the sign for is then to determine, once we have our reference angle, which quadrant we are working in, okay? So here, in this case, our reference angle is the same for both our solutions, one being positive, one being negative. And so that means we are asking the question, in which quadrant is sign positive to solve for this? And in which quadrant is sign negative to solve for this side, right? So sign is positive in the first and the second quadrant, right? So we're going to start with solving the positive side first, okay? In the first quadrant, you know that you do not have a reduction formula. It's just as it is. And so your general solution for the first quadrant looks something like saying beta is equal to 60 degrees plus k times 360 degrees. Hoping that makes sense. And in your second quadrant, you know that you have your formula. Just a pointer of note, guys, the reference to the R is the reference to the reference angle there, right? And so in our second quadrant, we're going to apply for beta being equal to 180 degrees minus 60 degrees plus k times 360 degrees. And that brings our beta to 120 degrees plus k times 360 degrees. This would be the general solution in the second quadrant. Then we move on to say sign could also be negative, right? So we're sign negative in our third and fourth quadrants. How do we go about resolving that? Simply in our third quadrant, the formula, the reduction formula is 180 degrees plus R, which is our reference angle. So beta at this point comes through to 240 degrees plus k times 360 degrees. And you apply a similar principle for your fourth quadrant, where you have a 360 minus the reference angle, and you come out with a beta of 300 plus k times 360 degrees. What you always remember to mention, guys, is that, so first, these are your four answers, guys. So remember, I asked for a general solution. I didn't ask for specific numbers. I asked for general solution. I did not tell you, I did not limit the quadrants that you will be working in. I didn't give you an interval. I didn't give you anything. I just asked for general solutions. So literally, because sign could either be positive or negative, all four of these are your general solutions. All four of these are your answers. And you never ever forget to write that your k is an element of integers. Because if from here on, I have to say to you, if I had to create a part 2 of this question, wherein I say, so I give you an interval for part 2, and then I say to you, within this interval, determine which values of beta are applicable. Now you will start by, in each formula, you will maybe substitute your k with a -1 to see if it fits in, to see which answer would fit in, your 0, and then your 1, and. So that's basically why I always advise from last week that you always start with getting a general solution before continuing on to find your answers that are values within an interval, should that be given to you in a question. Right, guys, if there's no questions, which it looks like there isn't for now, I'll be moving on to example number 2. Example number 2 says, determine the values of A in the interval. And guys, principally speaking, example number 1, example number 2 are quite alike. The difference with example number 2 is that now I have kept the scope in which you can work, right? I have said to you, you can only work from minus 180 degrees up to 180 degrees, right? Let's see our example. Our example is here. 2 cos squared A minus cos A minus 1 is equal to 0, right? You remember, guys, we do our usual factorization and well, I'm calling it the usual, guys. Please don't take for granted that it's just the usual. You just need to practice again to get back into the groove of this. I'm calling it the usual because we've done factorization when we were doing quadratic equations earlier in the year. And so I'm just hoping that I'm bringing back a blast from the past with these, right? From here, we're going to basically separate them. This will be one equation. You say this piece equals 0, and this will be your other equation where you say this piece equals 0, and you're going to resolve each one separately. So your thing looks something like saying this is 1, and it equals 0, and we're going to resolve that all the way down before we jump on to the next one, right? This is your 1, and it equals 0. And so what you're doing here is you want to be left with cos A only on the other side, right? So what you do from here, remember what I've always said to you, what you do on the left, you do on the right. And that's why we find ourselves at 2 cos A is equal to minus 1, right? From here, we also need to divide by 2 to remove the 2 from the left-hand side such that we are left with cos A is equal to minus half, right? And then from here, we calculate our reference angle where we key in cos to the power of minus 1 times 1 over 2 or 0.5, and we get that our reference angle for that is 60 degrees. Okay, and then we're going to do the second side of our, the second piece of our equation, where we say cos A minus 1 is equal to 0. We do what we do on the right to the left and vice versa. And that puts us at cos of A being equal to 1. And we find the reference angle for that being 0 degrees. All right. From here, we ask our usual question. In which quadrant is cos negative? So we'll start with one side and then we'll work on the other side. I like to work that way, guys, but the only reason that I bring it down per level, like I bring it down to a particular point each time, is just so that my thinking or my reasoning does not lag behind, where I have to start over completely when I'm doing the other side. But it's up to you guys how you do it. Even how you answer it on your paper is up to you. You could do it side by side, or you could do one underneath the other. However your mind works, please be comfortable as long as we get to the answer, as long as there's mathematical logic involved, right? So cos is negative in our second quadrant, right? And it's the second and third quadrant where cos is negative. So our second quadrant, we have our usual reduction formula where it's 180 minus your reference angle. And so we have A is actually equal to 180 minus 60 degrees plus K times 360 degrees. And that means that formula, your general formula in there says 120 degrees plus K times 360 degrees, right? In your third quadrant, we have 180 degrees plus your reference angle. So A there is actually 240 degrees plus K times 360 degrees. Please note how the question that has been asked is different, but the method in which we are answering has so far been the same as how we answered example 1, right? Then where is our cos 0? Where is our cos positive? In the first quadrant, we have 0. A is equal to 0 plus K times 360 degrees. And in our fourth quadrant, we have 360 degrees minus 0. And that gives us 360 degrees plus K times 360 degrees. Guys, surely, given the Cartesian plane, the availability of a protractor, we can all see that these two, the first quadrant and the fourth quadrant, where 0 degrees is involved, are actually the exact same thing. Hoping you guys spotted that. If not, remember your Cartesian plane. A revolution is a full circle that counts as 360 degrees. You have hopped around 360 degrees, but you have ended up exactly where you started, at 0 degrees. All right, so here we have our general solution first. Now what we do is we've been given an interval to find values in. So we will substitute, we'll look at each of our formulae and substitute our different integers. I like to always start with -1 and 0 and 1 as my integers that I will test in here to see if the answers to that will meet this interval. So we start by putting -1 in here, right? So if we say here, -1 times 360 gives us -360. So 120 minus 360 is -240. So that's not going to work for us, right? Then we put in the 0. When we substitute here using a 0, we're going to say 0 times 360 is 0. So 120 plus 0 is 120. Is 120 within the interval? 120 is within the interval. So one of our answers for A is 120 degrees, right? And then already from here, you can tell that should you substitute 1 in there, you'll have 360 plus 120, and you're already out of that interval. So you don't go there, right? The same applies here, where you say 240, if you substitute with a -1 first, so you'll have -1 times 360, giving you a -360. Then you say 240 minus 360 is -120. And does that fall into the interval? That falls into the interval, right? So you know your A is equal to -120 degrees as well. And you put in your 0. When you substitute for 0, it becomes 240 plus 0, and 240 is outside of our range, right? And then you substitute with a 1 as well, and you say 1 times 360 is 360 plus 240, and that's outside of our range, right? You apply the same formula this side, where 0 is 0 is 0. You apply -1 here, you get to a -360, which is outside of our range. You apply 0 and you get a 0. Is 0 in our range, guys? 0 is definitely in our range. And you apply 1 in there, you get 360, which is outside of our range. Same formula you apply here. If you put in a -1 here, then you know that you are sitting at a 0, which we already accounted for. If you put in a 0, you're sitting at 360, which is not in here. If you put in a 1, you're over 360, which is not in your scope. And so basically, what I'm saying to you is, because K is an element of integers, I should erase that for you guys to see better. Because K is an element of integers, as we previously mentioned, your final answer looks something like, say, A could be equal to -120 degrees, A could be equal to 0, and A could be equal to 120 degrees, purely because we've been given an interval wherein to work. Seeing no questions yet, so I'm assuming that we are all on the same page about how this works. So these are basically your two types of examples that you could get, guys. So what I'm going to do then from here on out, I'm hoping that I've explained the core principles of your QTEs from these two examples, because these are literally the two types of questions you would get. But if, as we go along, if we find more questions and we will be addressing them accordingly. I'll be picking up a bit of the pace with our coming examples because we're running out of time, but please stop me. Do not hesitate to ask if you're not getting my questions, right? Class example 3 looks like this. Cos squared alpha is equal to 0.64, right? Some of us are actually just maths geniuses, and we can already see that 64 is actually the same as 8 squared. So we could from here simply say cos alpha is equal to plus or minus 0.8. Sometimes we need to work it out a little bit, which is also quite good, which is also what I like, because it also helps your thought process. And when you strip it out, you come to factorizing it at a 0.8, a minus 0.8, and a plus 0.8. From here, we use one side at a time, right? We separate our equation, and we're going to use one side at a time, right? Let's resolve. So again, in this case, we have one reference angle. I was about to say, let's resolve our reference angle. And in this case, we can see we have one reference angle because it's both 0.8. The signage only comes in when determining what quadrant we should be working with, right? So our reference angle here is 36.9 degrees. If your paper says round off to 2 decimal places, you would have come out with a 36.87 in this case. And if they said round off to the nearest whole number, we would have come to 37 degrees, right? So we have our ref angle here. And how did we get there? On your calculator, cos to the power of minus 1 in brackets 0.8. Okay, leave out the signage when you are finding the reference angle. Okay, from here, we're going to start by saying where is cos positive? Cos is positive in our first and fourth quadrant. So for your first quadrant, you know that there is no reduction formula. Your reference angle is what it is. So the formula or the general formula in there says alpha is equal to 36.9 plus k times 360 degrees. For our fourth quadrant, where our reduction formula is a 360 minus, we know that alpha then ends up being 323.1 degrees plus k times 360 degrees. Note, guys, I barely gave you an instruction here. I literally just asked for you to resolve the equation. I did not tell you to work within a certain limit. I've just asked you to solve the equation, and that's what we are doing. So we've solved for our left-hand side where the cos is positive, and now we're moving to cos alpha being negative, which is your second and third quadrant. In your second quadrant, you have a 180 minus reduction formula, and that brings your alpha to 143.1 degrees plus k times 360 degrees, right? In your third quadrant, it's 180 plus your reference angle, and so your alpha there comes to 216.9 degrees plus k times 360 degrees. If the instruction does not exist, guys, this is where you stop. You remember to mention k is an element of integers. But, and so basically, these are your four answers. Your formula, your general solutions are your four answers. But what normally happens is they'll say to you, given your answer in part 2A of the question, part 2B is going to say, resolve for alpha in the following interval. That's how it normally comes out. And maybe let's say they give you an interval of 0 to 360 degrees, right? Let's say in part 2, they give you an interval of 0 to 360 degrees. What that means is you're going to do what we had done in our previous examples of taking our integers and substituting them into the k values to see what answers you can get that would put you in this range. And I'm just having a bird's eye view and saying to you, if you substitute 0 in all four of your equations, those are your answers. You would come out as saying alpha is equal to 36.9 degrees, alpha is equal to 143.1 degrees, alpha is equal to 216.9 degrees, and you'll also come at alpha is equal to 323.1 degrees. This is just me looking at it from an eye view if you substitute 0. But that, guys, is basically the flow of how things work with quadratic equations. What I've tried to do with my examples in class today is I've tried to bring up different types of examples so that you can apply different types of solutions. Please fill me in on what you think. Please give me your opinions, your feedbacks in the chat so that we can see what you guys are thinking. If there's a particular, let's call it a way that you would like me to go about doing this. Let's say you want to see something. Maybe, I don't know, you want to see how we would have gotten to the same answer if we had done this differently somehow. Please hit me up on that and I'm happy to give it a try for you guys. It can be the first things that we maybe look at in tomorrow's class, given the fact that we might just be running out of time a little bit. Example 4, 3 tan squared beta plus 2 tan beta is equal to 0. So guys, again, I'm not giving you instruction again. And I want to say to you, how you know you're working with a quadratic is the moment you put a square over your function. That's when you know you are within your quadratic equation. And so you're going to come out with 2 answers. So from here, we're going to factorize. This one has been put simply for us with the 0 already on one side. So we don't need to adjust, put the 0 on the other side or make the one side 0. No, the formula has been put in for us as it should be. And all we're going to do from here is factorize, right? When we factorize, we can all see that the common, let's call it denominator, with a common number, common factor. The common factor we can see from both our expressions, which are separated by a plus sign, is 10. Right? So we're going to pull out our 10, put it aside, and then we're going to be left with 3 tan beta plus 2 in a bracket. Right? So if you remember then our equations, we know that tan beta then forms its own equation equal to 0. And this also forms its own equation equal to 0, right? So we start with tan beta. With tan beta equal to 0, we come to a reference angle of 0 degrees. Then we move on to the right side where we're doing 3 tan beta. I've literally skipped the step where I would have said to you, you pull it out as 3 tan beta plus 2 is equal to 0. And I've just basically quickly done where you remove the 2 this side and you add the 2 that side. From here, you divide both sides by 3, just like that. And you find your reference angle here as 33.7 degrees. So again, you have a side where tan is 0, where your reference angle is 0, and we have a side where, well, your tan is 0. And we have a side where your tan is negative. So we'll start on the side where your tan is 0. Your answer where tan is 0 would actually simply just be 0 degrees plus k times 180 degrees. Reminder. Why are we using 180 degrees for tan? Because a tan graph, if you remember from functions from last year, which we will be doing as our next topic after trigonometry, your tan graph runs up to 180 degrees, after which you have a little undefined moment. And so it's the equivalent of saying you're starting a new graph or a new cycle. That is why we use 180 for tan. Remember that, guys. So yes, this is literally it for our left-hand side, because at which point do we have a 0? We have a 0 at the start or just before the start of quadrant 1, where you don't have a reduction formula. And this is our answer, guys, for the left-hand side. This is really just it for your tan is 0, right? Then for our right-hand, let me call it the right-hand side. For our second tan equation, where we came to a reference point of 33.7, we know that tan is negative. And tan is negative in your second and fourth quadrants. So we will apply our reduction formula as always, where we come to a beta of 146.3 degrees plus k times 180. Reminder, I'll keep reminding you. Where we talk 10, we talk 180, right? And then for your fourth quadrant, the same rule applies. It's 360 minus your reference angle. So your beta in there is 326.3 degrees plus K times 180 degrees. This is where you're finding your general solution. And if you're listing or jotting down your answer for your general solution, these are, okay, let me use a different pen. These three are your general solution answers. Because basically what I'm saying to you is beta could be either one of these on condition that your K is an element of integers. Again, if we had to take this down a notch and say to you within a specified interval, maybe we say to you, I should change pens. Maybe we say to you in an interval of minus 180 degrees up to 180 degrees. You know the relevant substitutions. You start by substituting your minus 1 in K, and bam, you have a minus 180 degrees. If your bracket is square, then it's included. But if your bracket is round, it's not included. Don't forget that, guys. Don't forget that. Right? And then here, if you apply your minus 1, you can already see that you're at minus 180 plus 146. So you'll get an answer of a minus 33.7, which definitely falls within this range. You apply that same formula here, and you get a minus 180 plus 326. And my head can't think, but I can see for certain that you are within this range. So that's how you go about it, guys. Hoping we're all good, all set. We are building up to the peak of our examples. We've got 2 more examples to go. Class example 5, we have sine squared p minus 4 cos p. Cos squared p. Guys, first instinct for me was to apply the identities, the Pythagorean identities. What a disaster. So what did I do? I basically took the cos to the other side, the cos p to the other side, and I said, what do sine, we've done such an example before where I said to you, what do sine and cos have in common? Hypotenuse. What doesn't have a hypotenuse? Tan. And so we're going to use tan to resolve this. So we're going to divide both sides by cos squared p to get a tan. It's almost like cancelling out the common factor. And we find ourselves having a tan squared of equal to 4. So if you're fast enough, as soon as you get into the groove of this, you'll be able to see that that means that tan p could either be a minus 2 or a plus 2, right? Or you can comfortably take your minus 4 to this side and factorize and say tan of p minus 2 times tan of p plus 2. And that'll get you the exact same answers, right? Right, just like that. And you'll get your same answers, right? Then again, you've got one potential reference angle because you are working with a same number of 2 on both sides. And I'll change pens to red now, right? Your reference angle is 36.4 degrees in this case. And we are going to say, where is tan positive first? 10 is positive in our first and third quadrant. For our first quadrant, it's simply 36.4 as it is, plus k times 180, 180 because it's 10, guys. And third quadrant, we have 243.4 at plus 180, plus k times 180. Whereas our tan negative second and fourth quadrant, we apply our usual reduction formula and we come out with a P of 116.6 degrees plus K times 180, or we come out with a P of 296.6 degrees plus K times 180. Remember, always state K is an element of integers. Last example, guys. Tricky, if I have to say so myself. So remember, I said to you, it's always best to try and get the one side to a 0 unless you can quickly factorize with your eyes, which I can't do. So what I did was I brought mine 2 to the right, to the left, by subtracting 2 on both sides. And when I got here, I saw that I still can't factorize. It's actually not as straightforward as I thought it would be, right? So what did I do? Just so I can see this properly, I substituted this with x, just for vision, so I can understand and rewrite this thing. And I said, it actually looks a lot like 2x squared plus 3x minus 2 is equal to 0. And I said, quadratic equations. What do we do when we cannot factorize? We apply our quadratic formula, right? Where you have your A, your B, and your C. Taking for granted, guys, that you have done well with your quadratic formula and you remember, we have a quadratic formula and we substitute everything accordingly, and I've worked it out step by step for you guys, and we came to a final answer that says x is equal to 3 plus 5 over 4, or x is equal to 3 minus 5 over 4. So that means x is going to be equal to 2 if we use plus 5, because that'll be 8 over 4, which gives you 2. And if you say 3 minus 5, that's minus 2 over 4, which gives you minus a half, right? From this point on, what I did, I substituted the x back to cos of alpha, and I came out like that, right? When you do that, it becomes simple all over again. It looks all kinds of familiar all over again. If we try to find our reference angles, a cos alpha of 2 is undefined, even 1 is undefined, guys. And so that means we will be working with this side only, the right side only. When we find a reference angle of 60 degrees and we say, where is your cos negative? And we know that cos is negative in your second and your third quadrant. And we're going to do our usual resolution, just like that, and come to 2 general solutions. Simply continued just as normal. Just because we couldn't factorize, all that we could do then was use our quadratic formula. Some people are actually comfortable with using cos of alpha throughout the formula without ever substituting for x. You guys don't get lost in the music. That's fine, if that works out better for you, right? And remember to state that your k is an element of integers, right? So what will we be doing tomorrow, guys? We are doing basically the last topic of trigonometry, which is your area, sine, and cosine rules in our triangles. If you guys would prefer that we do more trigonometric equations, please hit me up and let me know. I'm happy to accommodate you guys in my lesson prep, because next week, my plan for next week, this is a short week, guys. My plan for next week is for us to spend the whole week doing the revision of trig through questions and examples from past papers, right? So yes, I've set up links for you guys to use that will make things much easier for you guys. The YouTube link really shows you how to solve quadratic trigonometric equations. The Selvula link is a link to the textbook that I use for our classes, along with the examples that we use and the solutions, and it's got more questions in there for you guys. The purple math link will give you some more new problems that you can use. It gives you nice step-by-step answers, and your Khan Academy also has nice quizzes around that. That is the end of our lesson for today, guys. Thanks for joining. Remember, if you've got any questions, to hit me up on Twitter. I have not found any questions in the chats. Nobody has raised their hand, so I'm assuming that we're all good. These are our contact details for Africa Team Geeks. Whether you want information on more classes, information on the timetable, you can find these on Facebook, Twitter, Instagram, even on YouTube. And that is where, guys, you will find all the relevant information. So see you guys tomorrow morning at 9 o'clock, same time, same place. I'm Miss Shabalala, and thanks for joining me today. Cheers, guys.